Hello friend, I am Samati back with new tutorial video regarding RCC design. So in this video, I talk about the design constant value. Okay, because this video only for those who are very lazy. Okay, they are not preferring the hard work. Design constant value, that means we'll learn about first the modular ratio, right? Modular ratio, that is n. Then we talk about the neutral axis. In neutral axis, we find n in terms of kd. K is another constant. Then we find lever arm. There we basically find d minus n by 3. Yeah, that the L equal to d minus n by 3. So basically here the lever arm equal to some constant function of d and some constant. So this constant is known by J, and then we know the moment of resistance, that is known as your R. Okay, so what would be the value if we mention the grade of concrete as well as we mention the grade of steel, say Fe 250, Fe 415, Fe 500. Okay, this is the concept based on which we make this video today. Hope this is a great video for you. If you love the content, then definitely like the video. Okay, first we consider that M15, then sigma CBC, the value is 5. Modular ratio M should be 18.67, and if you use the mild steel Fe 140, then value of K should be 0.4, value of J, that is equal to 0.867, value of R equal to 0.867 also. Suppose the grade of steel equal to Fe 415, then K should be 0.29, J should be 0.904, R should be 0.65, and in case you are using Fe 500, then K is 0.25, J is 0.916, R is 0.58. This is for M15. What occur if the grade of concrete is M20, sigma 77, modular ratio is 13.33, the K value is same 0.4, 0.867, 0, and R should be 1.214. For Fe 415, K should be unchanged 0.29, J should be unchanged 0.904, and R is 0.914. K is for Fe 500, K is 0.25, J is your 0.916, R is 0.81. What happens if M25? The sigma CBC is 8.5, M is 10.98, The value of K for Fe145 is 0.4. J is 0.867 and R is 1.48. Fe415, K is 0.29, J is 0.904 and R is your 1.11. And if for Fe500, K is 0.25, J is your 0.916 and R is 0.985. So these are the few design constant value. But I recommend one thing, don't remember this thing, but you do some observation. Number 1, if grade of concrete increasing, sigma CBC already increasing. Number 2, if grade of concrete increasing, the modular ratio decreasing. That means M value decreasing. Number 3, this increasing, I mean to say more modular ratio, grade of concrete increasing, K value constant as well as J value constant. Number 4, M increasing, R value always increasing. So from here I can write M proportional to sigma CBC, M proportional to modular ratio. These all are the constant, so we can avoid it, and M proportional to R. So these are a few observations which is much more interesting, much more important for you. So this is a simple video where I discussed the design constant value regarding as per grade of concrete and grade of steel. Hope you understand, but still, if you have some doubt, do comment in the comment section. So if you find some value from this video, then definitely like the video, share the video with your groups, circle, and subscribe to the channel for more content. And thank you for watching this video. See you soon. Stay safe and stay healthy. Take care.